Chemistry video lessons, identifying reaction types. There are basically three types of reactions. One that forms precipitation or a gas, a product of the reaction that will not come back. Another that is an acid-base reaction, and the third which is called a redox or an oxidation-reduction reaction. If you move on into college chemistry and higher levels, this is what you'll be working with. However, in this class, you will need to break it down into the 5 basic formations, and they are single replacement, double replacement, synthesis, decomposition, and combustion reactions. Now we're going to go through each one of those with a little reaction statement, and I'll show you how to write those types of reactions, okay, so you can recognize them. Single replacement reaction. Here we have zinc chloride reacts with aluminum. Now zinc chloride, which could have been written here and sometimes it's not, is in an aqueous operation. It's not in a solid format. So when we write this, we're going to write zinc, and zinc always has a 2+ charge, okay, and chlorine, which has a -1 charge, so it would look like this. And we're going to add it to aluminum and then put our reaction arrow. Now this is what a single replacement reaction looks like. As you can tell, we have 1, 2, 3 different elements. Now if this would have been zinc phosphate, then we would have still only had 3, because the polyatomic ion of phosphate, okay, remember it looks like this, would be treated as an entire operation, okay? It would be one unit. We don't break it apart unless we absolutely have to. Now a single replacement reaction means that what's going to happen here is that the zinc, which is attached to this chloride, is going to be replaced by the aluminum, and the aluminum is going to say, no, I am more reactive than you are, and I'm going to take hold of that chlorine instead of sitting by myself. So what you're going to end up with here on the product side is we're going to have aluminum and chlorine adding themselves together, and zinc sitting by itself. Alright, now charges always have to remain the same. So one of the things we have to remember is what we talked about here a minute ago, was that zinc always has a 2+ charge, chlorine has a -1 charge. Now here the aluminum in its natural state would be 0, but it basically has a 3+ charge. So down here at the bottom, that 3+ charge is going to have to be added to this. So I'm going to have to write this as aluminum chloride would look like this, so it would actually be balanced back out now. Now on a double replacement reaction, we have more than just 3 elements that are going on there. So when we write the reaction here, we've got magnesium. So the first thing I like to do is put down my deals. I know that it is a 2+ charge. I got chloride, which we've already talked about, which is a -1. And we're going to add that to sodium, which has a +1 charge, and carbonate, which is one of our polyatomic ions, which has a 2- charge. So when we write this, we're going to write down magnesium chloride plus sodium carbonate. And now my charges all balance out. Now in a double replacement reaction, what's going to happen here is that they're going to swap. We can never put any of our positive metals, which is our magnesium here and our sodium here, together. So the magnesium here is going to swap and is going to attach to the carbonate, and the sodium is going to swap and attach itself to the chlorine. So when we write our products here, we are going to have then magnesium carbonate plus sodium chloride. And you will notice that the 2+ charge and the 2- charge of the magnesium and the carbonate balanced each other out, and the +1 charge of the sodium and the -1 charge of the chlorine balanced itself out. So now we have our reaction here. Magnesium chloride plus sodium carbonate will create magnesium carbonate plus sodium chloride, and that's what we mean by a double replacement reaction. Now a synthesis reaction means we're going to take 2 elements and we're going to put them together to create one. Alright, so right off the bat here we have nitrogen in gas form plus hydrogen in gas form is going to create ammonia. And ammonia is an NH3. Okay? Now, we have to remember here that whenever I have elements that are sitting here by themselves like this, I have to go Mr. Brinkelhoff. Brinkelhoff, let's see, that would be bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So right off the bat I can see that I have nitrogen and hydrogen are part of Brinkelhoff, so I know that they are diatomic molecules, and I have to write this. Now what this shows here is that I have these two elements here combining to form just one element. That's what's meant by a synthesis reaction. Now a decomposition reaction is just the opposite. We're going to take one molecule that has several elements in it, and it's going to break apart and form two other molecules. So as we can see here, we say sodium fluoride is strongly heated and creates sodium and fluorine. So I take sodium, which has a +1 charge, and fluorine, which in its ion state has a -1 charge, so they are actually balanced out now. And it's going to break apart and form sodium plus fluorine. Now remember, once again, I've got now a single element here that's sitting by itself. I got to remember Mr. Brinkelhoff, and when I remember Mr. Brinkelhoff, okay, I know that the fluorine is right there at the end in Hoff, so I have to put that as a diatomic molecule. So now I have my sodium fluoride breaking apart to form just sodium and fluorine. Now a combustion reaction is when something is burned, okay? And one of the things you have to have in every burning or every combustion reaction is oxygen. So methane, which you would not know, but I will give you the formula here. Methane is a single carbon and it has CH4. So that is a symbol for methane. And when you see ignited into a combustion reaction, we know we have to add oxygen, and it's a Brinkelhoff, so it has to be O2. Now in every combustion reaction, every one, always, never any doubt about it, if it is just got carbon and hydrogen and oxygen in it here, okay, I am always going to form carbon dioxide and water. This happens whether you're burning a log or whether you're burning sugar inside your body. Okay, you breathe out CO2 and you go to the restroom to get rid of the excess water that you have brought in because you've been breaking it down. Okay, this is what a combustion reaction looks like. We always will create carbon dioxide and water, and it will never happen unless we have oxygen that's added to it. Now, you need to review this as many times as possible, because one of the key elements of being able to pass a mandatory pass exam is being able to recognize what type of reaction it is, so I will be able to write down the products that actually form. Remember, when you're going through this and you have any questions, write them down so you can bring them into class and ask them so I can help you out, and never, ever, ever give up.